I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast that helps you understand the chemistry of your everyday life.
Jam, Thanksgiving is only 2 weeks away.
That's pretty insane. I love Thanksgiving.
I love Thanksgiving too.
I have no idea what I'm going to do other than eat food in some capacity.
I also have no idea what I'm going to do.
We should do another Friendsgiving thing like we did last year.
Yeah, last year was fun. I made a cake that looked like a turkey.
Oh yeah, that was cool.
It was really fun. And it was not an illusion cake. It didn't look like a real turkey. It looked like a cartoon turkey.
I was convinced.
And it was in the middle of us doing a fitness challenge.
Oh yeah.
And because of that, we went ham.
Yeah, we did.
Turkey Day.
Right. It was like that was the only allowed day to like not count calories.
Oh, absolutely.
Remember that? That was
yes.
so cool.
Mm-hmm.
I did go very, very ham on some turkey.
Ham on some turkey. I don't like the turkey very much, but that turkey was fine. Whatever.
Mm-hmm.
I don't like turkey very much in general, but I love mashed potatoes.
Yeah.
Bread.
Mm-hmm.
Mac and cheese. All the things.
Mm-hmm.
I love sides and desserts. And it's sad because I'm doing no sugar and no white bread right now because, just because of my health reasons.
Uh-huh.
And that's everything I love about Thanksgiving.
Yeah, there's a lot of sugar and white bread related things happening.
But I do let myself take breaks from it. I don't want to be someone who never eats cake again. Yeah. So I will fully, that's going to make Thanksgiving actually even better. I'm going to get to have, mashed potatoes are fine, but I'm going to get to have mac and cheese. Mm-hmm. I'm going to eat as much white bread as I want. And I'm going to make sure it's the good white bread.
Yeah. I feel like when you're pretty regimented and have some good discipline for yourself, letting yourself have an occasional, Thanksgiving is once a year. Letting yourself have an occasional, all right, I'm going to not count the calories today, makes it that much more enjoyable.
Oh, absolutely.
If you're not counting calories every single day, no offense to anybody, but if you're not counting calories every single day, then Thanksgiving is really no different other than just the food is better quality. But
it's with your friends and family.
Yeah, friends and family. But you don't get that heightened enjoyment that you would get if you have been kind of abstaining.
Yes.
And then you're like, all right, dude, Thanksgiving.
Yes.
Let's go.
So anyway, because Thanksgiving is only 2 weeks away and because we love food this much.
Agreed.
Then I decided to do yet another food-themed episode.
I love it. I love food. I love food episodes. I love how relatable it is to my life because I love food so much. So I'm ready.
Great. Okay. And I think this is relatable to everyone's everyday life.
Okay.
Okay. So when you cook bread, you toast some bread or you bake some cookies.
Yes.
Or you sear some steak.
Yes.
They get a little brown, golden brown. They get that nice toastiness on the outside or that sear on the outside.
Yes.
Do you want to know why it does that?
Because it's getting burned?
Well, kind of. Burnt things are a different thing.
Okay. So it's not like it's getting a little bit burned. It's something else?
It's something else.
Okay, interesting. I thought it was hitting that sweet spot. It's it's starting to get burned, but take it off.
I think now this is already something I don't know. You've exposed me early. I think burning is the formation of just carbon, like soot. Oh yeah,
because if your toast gets beyond toasted, it gets burned. It does just taste like ashes.
Yes, I think that's something else.
Okay.
I'm not 100% sure. It could just be what I'm about to tell you taken all the way to the end.
Okay.
But I'm already not sure about something you said.
Oh, sorry.
So that doesn't start out great for me, but that's okay. I'm fine with not knowing things. Okay, so I was told in college, I took what's called a polymer chemistry course. And in that course, we had a visiting food scientist, I think from Pepsi, but I don't know for a fact.
Interesting. Pepsi.
And he said that the toast that forms on your bread, that brown color, is a polymer reaction.
Oh.
Yeah. And I took that and I knew it. And that was all I knew for the last probably 7 years. But I've had that in the back of my mind.
Yes.
Separately, my brother wanted me to do an episode on why things turn brown when you cook them. Guess what?
What?
They're the same. The polymer reaction he told me about and my brother asking about why things turn brown when you cook them like steak is all the same concept.
So the Pepsi guy food scientist. What was he talking about turning brown?
Well, he was talking about bread. All he talked about was bread.
Okay. And then your brother asked about other things that are not bread.
Like steak and stuff.
And it's the same thing happening.
And it's the same thing. And so I finally got to open the door to that man telling me that thing and explore around in it.
A leftover mystery, unsolved.
Yeah.
Now being reopened.
Yes.
The case is being reopened. And
it wasn't even so much a mystery as I knew one level of fact, and I knew there was a lot deeper to get in.
Yeah.
And I never had the time or the reason to go and look into it.
Yes, got it.
And so I finally got an excuse to open that door and look inside.
And
I learned so much.
Excellent.
I'm so excited to share it with you. So I'm going to talk to you about what polymers are,
okay,
why that stuff turns brown, and some of the ways that we can control that reaction.
Okay.
And then I want to hear you tell me about it.
Perfect. That sounds good.
Okay, so first of all, do you know what a polymer is?
I think I've heard that word used in a way that kind of seems to suggest it's a mixture of different things. That's a really like broad definition. But like some plastics, I think, or some like coatings or whatever that are like some mixture of different chemicals. That's pretty much it. That's all I've really heard it referred to as. It's one of those like nice advertising words. It was like, our patented polymer whatever coating keeps your stainless steel products, you know.
Yes. So polymers are, the very basic definition is a large molecule with repeating small groups in it.
Oh, okay.
So it's called a macromolecule, a big molecule, and it has a bunch of small groups that just repeat over and over and over again. Okay,
it's a molecule with a lot of smolecules. Repeating over and over again.
That's so good. Yeah. A big molecule with a bunch of molecules inside repeating over and over again.
So inside, not like a tail kind of thing, like with the soap deal. It's like a lot of, it's containing the small ones?
Well, it basically can arrange itself in a lot of different ways.
Oh, okay.
But imagine it's a chain of ABC, 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 ABC over and over again. So the small repeating unit is the ABC, but they're all connected together in a variety of different ways to make a larger molecule that's known as a polymer.
Within the larger molecule, there's a pattern of some kind that's kind of small. It's like not like 26 letters. It's like 3 or something.
Yes.
Like that. Okay. Got it.
And those small units, small repeating groups, it could be varying sizes. It doesn't have to be anything in particular, but that's just the overall definition of a polymer, a large molecule with repeating small groups.
Okay.
And polymers, like you said already, make up so much. Nylon for nylon stockings. Polymer.
Nice.
Plastic. What is this? My sister calls these church tables.
They are like that. Yeah, I don't know what they're called. It's a folding cheap table.
Yeah, I don't. They're like the church lunch tables.
Underachieving table might be one of the phrases you could use.
This table is made of polymer.
Okay.
And the nice toasty part of your toast is a polymer.
Okay.
And the sear on the outside of your steak is a polymer.
Okay, interesting.
So polymers occur naturally, and we can synthesize them in the lab. And now we're going to talk about how they happen in our food reactions.
Okay.
So do you got it? Do you know what a polymer is?
I think so far. I mean, like, there's still a lot that I don't know, but I think I have the basic definition and hoping it'll make sense when we delve into the food part. So it sounds like a polymer is a large molecule, but within it, there's a distinguishable pattern of some kind. Some smaller unit that is the same repeating over and over.
Great.
I don't know what that would look like really, but it sounds like we're going to have some specific examples.
Yes, we are.
Okay, sweet.
Polymer chemistry, though, is very complex. So we're not going to dig in as deep as a polymer chemist would.
Okay.
And there's some that just wouldn't be fun or even possible to communicate on a podcast. But I'm going to do the best I can.
Okay.
So now you've got what a polymer is. You can put that off to the side for just a second. And I want to talk about just basic chemical reactions.
Okay.
So in chemistry, there are special arrangements of molecules known as functional groups. So if a carbon, oxygen, and a hydrogen are arranged in a certain way, that's a functional group. Okay.
Okay.
And usually what happens in a reaction is one of those functional groups reacts with another functional group to make and or break bonds.
Okay.
And that is a chemical reaction. So usually it's different groups of atoms arranged in different ways that have a consistent way they interact with each other.
Mm-hmm.
Okay. So you got that.
Mm-hmm. So they interact and bonds change of some kind. And that's that's what a chemical reaction is.
Mm-hmm.
So different groups of atoms together into molecules that interact. And when they do, bonds change in some way.
Right.
And then that's a chemical reaction.
Right.
Okay.
They're either made or they're broken. They change in some way.
Okay.
You can have a chemical reaction just between two elements, but right now we're talking about in molecules.
Okay. Okay.
So now let's take our polymer knowledge and our chemistry reaction knowledge, and I'm going to tell you what happens in browning food.
Okay.
In browning food, there are two types of functional groups. Say that definition for me again.
They are groups of atoms and molecules that when they interact, I guess the functional groups themselves are just groups of atoms that have a particular way that they react together or something.
That's close. They have a particular way that they're arranged.
Arranged, okay.
Before any reactions take place, they're just arranged in a special way that are recognizable.
Okay.
So these functional groups that naturally occur in most foods, there are sugars, and there are special types of sugars with a special functional group on them. And there are amines, and amines are made up of nitrogens and usually some hydrogens. And those naturally occur in meat, like in proteins, in all the things that are in food. In browning food, these two specific groups, one functional group called an amine, one functional group called a reducing sugar. Well, a reducing sugar is really a group of functional groups, but that's neither here nor there, will react with one another. Okay?
Okay.
When they react, a whole cascade of more reactions will then start to take place.
Okay.
And when that whole cascade of reactions start to take place, you get so many things that you recognize in cooking.
Okay.
So they can take one direction or another direction depending on what is present in the food. They can stop and release into the air as what's called aromatic compounds, so you can smell them. Those are cooking smells. They can keep reacting and make up a large molecule with small repeating units called a polymer that's brown and has a delicious flavor. Interesting.
So that the smell and the look combination are part of the same deal. They're both effects of the same reaction that started a chain reaction kind of deal.
Yes.
Okay.
Exactly.
That is interesting. I hadn't thought much about the fact that I don't know, I just hadn't crossed my mind. Probably like many of us, but the idea of the smell and the look of something cooking being so tied together, just I haven't thought about it. It's just you're so used to things that you cook that you love smelling great or whatever. It's just he's cooking, so it's going to smell. I'm going to smell it. But the fact that it's part of the same kind of initial reaction that causes several different things or whatever is cool.
Yeah. So yeah, I'm so glad. Yeah, I was reading this and I learned a lot in this adventure, and it never occurred to me either that the thing that I knew that was a polymer. I didn't know how it happened or what molecules it was between or anything, but it never occurred to me that could also be possible for smells.
Smells are so crazy too. And I know you've, I think we had a question or something like that related at some point that maybe we'll someday do a smell episode.
Yeah.
So obviously don't want to go down that rabbit hole too much, but oh my gosh, the idea of whoa, the thing smells sweet or smells like whatever is crazy, especially knowing what other reactions are going on. It's weird that we can also not just see it, but smell it. I don't know. That's such a stupid thing to feel amazed by, I guess, but it's kind of cool.
Well, I think it's really cool. I don't ever think things are stupid to be amazed by. I try to really embrace the wonderment of normal things.
Well, yeah. Do you ever say something and you're like, oh, it's so crazy that this is happening? And you're literally just saying what's happening. You're like,
yes.
and people are, it's like, you kind of feel like a complete idiot because it's like, yeah, that's what happens. You put dough in the oven and then it bakes. Like you're just saying what happens. We all know.
Yes.
And you're just adding that's amazing at the beginning of it. You kind of feel a little bit like you just woke up from like a coma or like somehow you were born.
I'm fine with the way that feels to be the one that thinks, isn't that so? It's about food. Isn't it amazing that there are so many different things we can do with just the same ingredients? And then people are just like, yeah, whatever.
Yeah, I think there's sometimes where I find a different way to put it. Different way to word it, and then I feel like, okay, I'm going to say this because I'm not going to sound like an idiot. But if I'm just saying, like, isn't it crazy that like you put this like wet, gushy stuff in the oven and then it becomes like soft, but like rises and then tastes good? It's like, yeah, we've all done that every day, basically.
You can just say that to me, and we can just be amazed together.
Right. As long as I won't sound like an idiot, then yeah, I'm happy to know that you won't think I'm an idiot.
No, I won't. I'll be excited too. Okay, so what I just told you, those are the very basics of what's called the Maillard reaction.
Maillard.
It's spelled almost like mallard duck. It's Maillard. I think it's French, Maillard.
Oh, nice.
It was discovered in 1910, I believe, by someone who was doing research about diabetes. And there's a lot of research that still goes into this reaction. So there's still a lot to know and that we need to know. We know the very basics. It happens in a lot of food. It makes food taste better to most people.
Yeah.
It makes it easier to digest for our bodies and to get nutrients out of. It's favored at high temperatures. I think it has to be slightly above the boiling point of water, like 218 Fahrenheit, I think, for the reaction to be triggered. You want to have low moisture because water can sort of get in there and mess up some of that reaction. And you don't want a lot of acidity because we talked about this briefly before, but acids and base react, and the amines that react with the sugars are basic. So if you have a very acidic marinade on your meat, for example, and then you try to brown it, it might not be able to develop as many of those good flavors because some of the molecules that are trying to react have been quenched, knocked out, not able to react. They've already reacted with the acidic marinade.
Interesting.
So those are the big facts about Maillard reactions.
Okay.
But they are still studying these because different groups of molecules attached to the basic functional groups, the amines and the special sugars, will make a myriad of different flavor profiles. There are nutty flavor profiles, ones that taste meaty. That's the umami flavor that they talk about. Ones that taste sweeter. All of these, all the flavors that you experience when you cook food and the things that you smell are all from these incredibly complex Maillard reactions. And we could dig deeper, but even as I was studying, some of the papers said, hang on, let me find the exact wording. It was really good. Even when I was studying, one of the papers said several steps between two reactions. And you can go look at another paper and look at it. But for a chemistry paper published in a peer-reviewed journal to say several steps, you know that that's complicated.
Yeah.
So it is a very complicated reaction, and there's so much left to learn about it. But those are the basics and the big things for you to know about why food browns and then tastes better.
Interesting. You know what I just thought about too is that like me saying, isn't it just kind of burning at the beginning? Is me using a really simple word to describe something I don't understand at all. I don't understand what something burning. I do not understand the first thing about that. It's just familiar. And so I was like, oh, isn't it not something burning? But I don't even know what that is.
You don't know what burning is?
No, I mean,
we can
none of us
absolutely do an episode about what happens when we burn things. I'm going to write that down right now.
Okay, perfect. But I mean, like, I think a lot of us would do that, but then not really think about like, do we even know what burning is? Like, or we're just familiar with it because we've encountered it many times when we've left something too long or when we've made a fire or something like that. It's just like not we don't really know what's actually going on. So,
well, and I did read that if you let the reaction go on for too long and there's too many of those compounds, it does start to get some of the bitter flavors, and that could be part of the taste that we associate with burning. But I do think that the actual combustion reaction of burning is going on, but we can talk about that later. So that's it. Those are the basics of the Maillard reaction.
Okay. So is this the part where I try to describe back to you what all of that is?
Yes, please do.
Okay. Firstly, a polymer is a large molecule made up of repeating smaller units within it, patterns. And then a functional group is a set of atoms that arrange themselves in a recognizable way. And then they can interact with other functional groups and cause reactions that are different based on what's going on.
Yes.
And so, this is going to be hard because we started talking about a lot of other things since we actually finished the chemistry part. Delicious things. Okay. So in an oven, so to speak, or some other thing where something's cooking and browning, a toaster, whatever, you said two things. You said there's an amine.
Yes.
And what's the other thing?
There's a special type of sugar.
A special type of sugar.
It's called a reducing sugar. It doesn't matter. It's a sugar with a special functional group on it.
Okay.
It means nothing to most people. It's just a special type of sugar and a special type of amine, and both of those naturally occur in food.
Okay. And so that's present. And also the temperature is hugely important. So when things get above, essentially like boiling point, above 212 Fahrenheit, at that point,
I think it's 218, but I don't know for a fact.
Okay. It has to be pretty hot.
Yeah.
Which makes sense. That's what we all see. But then those functional groups can react. Is that what's happening at that point? And then they form a polymer?
Yes.
Well, a lot of reactions happen.
Yes.
One of them is that a polymer is formed, which is that also related to the sugary taste kind of deal? Or like some of the taste related things is the polymer that we're tasting?
Yes.
And then aroma happens too.
Yes.
It might be its own reaction, but it's all related to the initial heat and functional groups reacting.
Yes.
And then it's like all these things happen.
Yes.
And it's, to us, it looks like look, taste, and smell. Yes. But it was probably who knows how many things going on.
But those are the basics. That's a great description.
Okay. I was pretty scared because I was like, I know the definitions of the things, but then it's like that crucial moment. I'm like, wait, what really did happen?
How do I put it all together?
Heat and some stuff that's already there.
I thought of a really good illustration for it while you were talking.
Okay.
I have been trying to think of a good illustration for this for several hours over several days, and I've not been able to come up with anything. But it's almost like when you set up dominoes, you know, and sometimes you have them just in a straight line, but you can have little offshoots. That's the best way to describe a Maillard reaction, because you knock down the first domino, that's the sugar and the amine reacting. And then there's all these little side products for that form. So if you've set up the dominoes in the right way, they can go out on the side, but then that main line keeps going. And in the end, that main line will form the polymer. But the side chain reactions that are going on are also smells and all that other stuff.
Have you seen V for Vendetta?
Once, a long time ago.
There is a scene where kind of like the climax of the movie, the main plan he's plotting. There's some tension building, and he does set up a large domino thing in the shape of a V, because that's his name or whatever. And so he first pushes we've all seen domino reactions, but he first pushes the very tip of the V, and you don't really know what he's doing. And then you just see it zoom out, and it's like this huge thing, but it splits off like that, obviously. Yeah. And it's like crazy to think about, like 1 to 2 to 3 to 4 to 5 or whatever. It can just so easily fan out like that. Yeah.
There's so many little exits and side reactions that can happen that can make different things. And we really can't get into this because it's so complicated, but based on what type of amine, like what's the functional group attached to, that gives you different flavors and different smells. And that's why different things taste differently. There's just a lot of options for you there.
And you said amine is basic. Okay, so it's like not... Is there any relation word-wise to amino acids?
Yes.
Okay.
Okay, so amino acids, I thought that this was true, but I got really scared because I wasn't a great student in college. I was going through it. I was a really good student in high school. Yes.
Killer student now, though.
Yes, I was a really good student in high school, and I was a solid A- B+ student in undergrad. Average, but that means there's some definitely worse classes in there.
Yeah.
And then I got to grad school and really locked in again. I was going through it. It was a hard time. Self-discovery, you know?
And look at our Instagram today for the photo from this episode to see one of her worst tests. We'll post a photo of that.
Absolutely not.
Oh, okay.
I didn't keep them. I probably just burned it.
I'm just kidding.
But
burned, nice.
But amino acids came into play most often in biochemistry. I did bad in that class. I did badly. I did bad.
Badly, I don't know.
I didn't do well in that class. But amino acids they all have amine groups in them, which is what I thought, but I just wanted to be positive because I hadn't checked that before.
Yes. Interesting. I was like, that's sounding familiar. But then I didn't really think about it until you said the basic thing, being base. And I was like, oh, amino acids obviously have acid in the name.
Yeah. So base in the same way that the other episode we talked about with acids and bases in baking soda.
Okay.
So acids will react with them. So that's why acidic marinades, I think that's part of why they break down food and make it more tender.
Oh, okay.
But it can also inhibit your Maillard reaction and keep the brownness from coming. Also, I forgot to say, Maillard was studying this type of reaction, I believe, because he was looking into diabetes.
Oh, you did say that.
I did say that? Okay, good.
1910?
1910. He was looking into diabetes.
Yeah.
And that's why he sort of discovered it by accident. A lot of chemistry discoveries are accidents. Many people have won Nobel Peace Prizes for accidents that they made. So that's it.
Wow, that's awesome. So did I already say the whole thing back pretty much earlier?
I think you did. Yeah, the high temperature you talked about. You want low moisture, but that's not incredibly imperative. And it's between sugars and amines.
That's kind of interesting too, because you think about the moisture aspect. It does seem like if you have moisture in something that you're trying to cook, some of it does have to kind of get out of the way before the thing starts happening. Like vegetables or whatever, it seems like some of the water that's naturally in there has to kind of start evaporating off before you even notice any amount of like browning or whatever.
Yeah.
Which I never thought it was related.
But it definitely is. So that's it. That's how, now when you're cooking and you're getting ready for Thanksgiving, after you've chopped up your onions and you know why you're crying, and then you throw them in the pot to saute them and get them brown, you know that is a Maillard reaction. So you can talk about the airborne things that come when you cut an onion open and how that forms at the moment you damage the onion.
Yeah.
And then you can talk about the Maillard reaction. So definitely invite someone over who doesn't listen to this podcast and teach them all of that.
Yeah.
And then tell them where you learned it on Thanksgiving.
Yeah, that's a good combo right there. The onions thing, almost certainly something you're making is going to have onions in it. And then everything you do, almost everything except for like maybe a salad or something, is going to have the Maillard reaction in it, right?
Yeah.
Yum.
Yeah, we've got a good food series. Now I'm a little bit hungry. Some nice brown steak. I love steak. I worked at Texas Roadhouse for a very long time. So, all right, Jam. Well, what are you thankful for this week?
Thankful for.
All right, we're going to do our thankfuls.
This week I've been thankful for my roommates. So my wife and I think I've described this a couple times, but just in case you haven't heard that episode, my wife and I live with another couple. We kind of have a house that it's sort of like a duplex. We share a living room and kitchen. And so we have different sides of the house, though. And so my wife and I really love living with the couple that we live with. And we got to have a cool roommate night this week where we went to the fair.
Oh, I love that.
Yeah. And it was just really great, really good hang time. We really enjoy getting to live with them. And so I'm really thankful that we get to have a cool sort of family in our house here. So we really, really like that. So I've been thinking a lot about how thankful I am.
And you guys do a really good job of letting your home be really open to everyone. You have a lot of events over. You always invite people over. And I love that you all have decided to make your home be like that. Yeah.
So that's what I've been thankful for. What about you?
I'm thankful for that too. That's not my thing, but I am thankful for that.
That's kind of cheating, but I'll allow it.
I think my thing that made me happy this week, a few episodes ago, you talked about putting Mario on your phone. Was it Mario?
Oh, yeah. Actually, that was that they came up with a Mario Kart app. And then this is something different. But yeah.
And I said I would be eternally delighted if I could get the sounds and sights of my old Game Boy Color back. And Jam did it for me.
Yeah, I accidentally that same week stumbled across a way to do that, and I was not looking for one, which is kind of funny. But I was like, I want this too. And then Melissa just talked about that, so it stuck out to me.
And then he did all the hard stuff where you have to download stuff and put it on my phone, which I'm so bad at that stuff. Updating my computer, forget about it. I don't know how to do any of that. And I got to play it after I had a big project for school. And it was such a fun day to just play with and it was even purple, which was the color of my Game Boy Color.
Yeah.
And it had all the sounds, and it really was just pure nostalgia.
Yeah. And if you're listening, you might know this as an emulator. It just plays Game Boy games. But it's super, super fun.
It is super fun. I don't know anything
old
about
games,
emulators.
But it's just called an emulator. But yeah, they are way fun.
It was very fun to be back in that nostalgia.
That's cool.
Yeah.
So before we totally wrap up for the day, we've got some updates on listeners around the world. We added a new country.
Oh, yeah.
This week, Romania.
Ayo. I'm so excited about that.
Yeah, it's awesome. First listens from Romania. So, hey, Romania, how's it going? We had two kind of significant jumps in two countries. Australia jumped from like I think 50s or something like that to the 70s
very quickly
in terms of listens. So that's pretty cool. It kind of been a slow incline. And then Germany jumped from like 70 something to 120 something, right?
Very quickly, yes.
So awesome. Thanks Germany and Australia for listening.
Yeah,
and
thanks,
Romania.
Guys. And I'd like to also give a thanks to our references. So I used several peer-reviewed journal articles this week, including one called Control of Maillard Reactions in Foods, Strategies and Chemical Mechanisms by Lund and Ray. I used one called Baking Aging Diabetes, A Short History of the Maillard Reaction by Helwig and Henley. And then an article I found on a Science Direct database called Shelf Life of Food Powers by Hedegaard and Skibsted. I hope that's right. And Handbook of Food Powers. And last but not least, an NPR article written by Joe Palka called 100 Years Ago, Maillard Taught Us Why Our Food Tastes Better Cooked. So thank you to all of those resources. And thanks to all of you guys for listening.
Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. And if you enjoyed this podcast, you should tell one friend about our podcast this week. Because if everybody told one friend, then we'd actually just double overnight in listeners. So
double the number of people learning about chemistry.
Yeah. So that's a challenge to you this week, so that we can help share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and we'd like to give a special thanks to A. Collini and In Newell, who reviewed this episode.